You're explaining very nicely.
Okay, thank you. Okay, so the velocity, if you see, yeah, so here once you click on velocity inlet, right? It is cold inlet basically. If you see, the name is cold inlet, and then we are having multiple options like magnitude and direction. We have components, we have magnitude and normal to boundary. So generally, what happens? Uh, like usually magnitude normal to boundary is most preferable, because generally when I say the velocity at inlet, let's say 5 meter per second, so it becomes like 5 meter per second is magnitude, and normal to boundary, like this boundary, normal to boundary, the arrow you can see, blue arrow, these are normal to boundary. But if you have some other boundary condition, let's say component, if you have, so you can define component as like what is x velocity component, what is y component, what is z component, right? And anyway, in our case it is magnitude and, okay, one more thing, magnitude and direction, so you can define that also. You can define magnitude and in which direction it is coming, right? So that also you can do. Anyway, so for our case it is magnitude and normal to boundary. The For cold inlet, now check what is the velocity at cold inlet. So that for cold inlet it is 3 meter per second, so we'll define here 3, right? Everything is done here. By default, turbulence intensity is 5 and turbulence viscosity ratio is 10. For most of the problem, these values work. But if you want, you can calculate the same from there are formulas to calculate turbulence intensity and viscosity ratio based on uh, characteristic length of this thing model, right? But we are keeping default value, and then we will move on to the thermal. Thermal side, if you see the value right now, it is in Kelvin. If you want, you can change this to centigrade. So we'll simply go to the units here and then click on T. When you say T, it becomes temperature. Yeah, T. So click on C and close it. So see, now it is centigrade now. So what temperature it is there? It is okay. I think it should be here. Yeah. So 10 centigrade, 10 degree centigrade is here, and 90 degree centigrade is here. This is your 10, right? Come to the hot side. Again, everything is same as we have defined earlier. So we will define velocity as 1 meter per second, and temperature as 90 degrees centigrade. Click on apply and close it. These are the internal thing that uh, there is nothing to define for internal. And then outlet. What is outlet side? When I say outlet, it means this pipe is opening where this pipe is open. So in our case, this pipe is opening in atmosphere, right? So we will define what is the atmosphere pressure. So that atmospheric pressure, we are talking about the gauge pressure, right? So that gauge pressure becomes zero, right? So by default it is zero. And what about the ambient? There should be some ambient temperature, right? So that ambient temperature, check how much ambient temperature is. Oh, it is not defined. Oh, ambient is not defined. Well, so what we'll do, we will define ambient from our side. Let's say it is 27. Anyway, we just wanted to understand how the process works. So any nearby value we can define, right? So everything is perfect now. We'll close it. And at the end, we have wall, right? So if you remember, the wall is adiabatic. See here. Yeah, this wall is actually adiabatic. Somewhere, I think somewhere there, it was written adiabatic wall. Yes, it's a adiabatic wall. So that means there is no heat transfer. So heat flux is zero, right? And click on apply simply. There is nothing more to define. It's a stationary wall. It is not moving with respect to something, or right. So we are keeping default options as it is. Similarly, for thermal also, we are keeping default options as it is. Okay, fine. So we have defined cell zone condition, we have defined boundary condition, we have defined the models. Right now, we will move to the methods. So under methods we have schemes like simple scheme, we have simple C, then piezo coupled, right? It's a simple problem. So for simple problem, I mean simple in the sense it is with fluid flow and heat transfer in a simple geometry which is T-shaped pipe. So we will select simple problem. Don't get confused like the name is simple, so it is simple. It's a acronym basically, and then we will keep everything as default, and then we will move on to the report definition. So okay, so what we do report definition, we will here uh, tell the software that these are the variable, or we can say these are the things we want to look into the results. For example, temperature. So click on new surface, area weighted surface, right? Area weighted surface, that means what it does, it for see, if you see, there is, for every cell there is some certain area. So whatever value we get for this cell, that divided by area, right? And the same thing will happen to all the cells. So it will get sum, and then finally we will divide it by this whole area. This become your area weighted average, right? So for example, this is A1. Let's say the temperature is T1. So A1 T1, A2 T2, A2 A3 T3, A4 T4. So A1 T1 plus A2 T2 plus A3 T3 plus A4 T4, and so on, divided by total area A. By doing so, whatever value you get, that becomes your area weighted average. So we'll select here like our interest, quantity of interest is temperature. Temperature where we want to see it, we want to see it at outlet, right? And click on OK, right? Similarly, there is another. Let's say we want to, what else we want to see? Okay, we want to see the this thing velocity, right? So again, go with area weighted average. Here, right? Let's say velocity, and select velocity over here and outlet, right? This option we forgot to define. Okay, we will define here temperature. Okay, fine. Residual. Uh, so I think you all have gone through the CFD course. So residuals are basically the uh, the kind of error we can say which is or the difference between the solution of first and second one, right? So what happens in Fluent, if the three or four consecutive iteration results are having difference value less than this 0.001, the solution will get stopped, and it will tell you yes, we have achieved the solutions. So by default, whatever values are listed over here, they are good enough. We will keep them as it is, and we will click on OK, close it, right? Yes, and now these are the file which we are going to see. Earlier, right now there are separate file for this thing is temperature. Actually, it is not updated. Just 1 second. This is temperature, and second one is velocity. What is going to happen now? You will get two files saved for temperature data and one for velocity data. Now, if you want, you can collect both the data in single file. So, how to do that? Click on new. Let's say I'm writing over here new, or let's say combine of these two. So now we are going to get file which will have data of both, right? Uh, and where are these file going to save? It is going to save in the work directory, which is your work directory, this one, and it is Jalandhar, right? Here we will get all three file. Okay, then we are going to see the plot over here. I'll show you once the this thing uh, we will run the solution. We will get this value, right? Okay. Then finally we'll go to the initialize. So there are options like hybrid initialization and the standard initialization. When you say hybrid, what happens? The Fluent iterates Fluent does some iteration. They are basically 10 iteration. What it does, it takes value from the boundary, and it it find out some initial values based on the 10 iteration uh, under this hybrid iteration scheme. And then second one is standard iteration, standard initialization. Here you can define your own values. So by default, you can see there are some values are 0, some values are 1. So either you can keep them as it is, or if you want, you can change it. Also, if you want, you can compute it from wall or outlet or something else, right? So let's say we are going with hybrid, and then click on initialize. Once you click on initialize, as I said, it will do some iteration. So it has done 10 iteration, and finally the initialize is done. So now what happens? We have got some value in the cell, because there are 10 iteration already. So we have got some value. So let's check what value. See, still the solution is not over. I'm just telling you, we based on initialization, we have got some value. Now check. So we will see what we will see. We'll check what is the velocity and then what is the temperature. So select contour of velocity, and where we want to see it, we want to see exactly at the center, exactly at the center. So we will make a new plane, go to the new surface and then plane. See, it is exactly at the center, right? Or maybe I think you make it 0, that will be more clear, and click on create, right? So we have got this plane 4, and click on save and display. Before that, okay, anyway, we will click on save and display, right? So this is how the values you are achieving. Like, this is velocity, here it is 1, and here it is, let how much it is, uh, around 3 or around 4, something around here. Anyway, we will range it to 0 to, let's say, 4, and click on 4. Maybe let's okay, I think. Okay, and similarly we can make another this contour is velocity contour. We will write here as velocity. Second, we will make temperature contour. So under temperature, go to contour of temperature. Everything is same. So this is temperature contour. Now we will define the range again here. So let's say from 10 to 90. And click on close, right? Now what we will do, we will monitor these two quantity. I want you to check like how the results vary with respect to every iteration. So after defining this contour, go to the calculation activities, and then if you see here, we have an option called solution animation. uh, Under this, I want to generate an image that is in JPEG format after every 10 iteration, and I want to save it in some directory. So that directory is, let's say, this is what, this is velocity, I think. Oh, let's say it is velocity animation. Okay, one more thing, view. So I will save view as save. You want to see velocity with this particular view, and click on OK. I will, okay, here also make as velocity. And second one is your, I'll copy it, really more easy. Temperature animation. So this will have another folder. Let's say this is temperature animation. So okay, so why it is velocity? Oh, because we have not selected temperature, so we have to select temperature over here. Now check. The view also we have not selected. So this is view. Right now everything is done. Now we will go to the so ultimately what we have done till now, I'll recap this. We have defined boundary condition, we have defined cell zone condition, we have defined models which we are using, right? Then we have gone to the see this is what till here it is pre-processing. Now and from solution onwards this becomes your solver part. So under solver we have defined method, then we have defined report definition, like we are going to capture velocity and temperature with respect to iteration, and there will be our main key point when we talk about results. And then report file, so basically under report file whatever you are doing here, it will get generated in terms of text file. uh, Okay, fine. And then initialization, I have informed you like there are two types of initialization. One is hybrid, second one is standard. Uh, we have gone with hybrid initialization. And then under calculation activities, there is a option called solution animation. Here we can animate your quantity of interest. So we are animating temperature and velocity with respect to iteration. And for that you have to create temperature and velocity contour. After initializing you have to create temperature and velocity contour, right? So this part is done. Now we will go to the run calculation, and let's say if I define here 500 and click on calculate. So if you see the after every 10 iteration the picture is changing. See, after every 10 iteration this picture is changing. And these are the residuals. See, the residuals are moving down, right? So once they achieve this 10 to the power minus 3 range, it will stop. I think this the time is now 5 o'clock. It has already crossed the reach, the limit. Basically it was 3 to 5. So shall we continue or what? Hello? Hello? Is anybody over there?
Just wait.
Yeah, so I just wanted to know, see the time is 5 o'clock already.
No,
5 is
you can take your time. It is highly interesting. Everyone is keen to know.
okay, fine. Okay, so as I said, as it reaches 10 to the power minus 3 criteria, maybe you can see it over here. Uh, at 148 rotation, it was 1.05 10 to the power minus 3. At 149, it becomes 9.91 10 to the power minus 4, right? So here it got stopped at 149. So the solution is converged at 149th iteration, right? And now let's check other things also. So this is your starting temperature contour. This is your velocity contour, right? And then this is your area weightage temperature value here. So it is 146, which is sorry 25 degrees centigrade approx. And this is your velocity. So if you see the y-axis, it is like 3.43, 3.43. So although you are seeing some sort of zigzag value, but they are nothing but more very close to 3.43, right? So your result is again 3.43 only, right? Anyway, so now I wanted to show you like how you can make animation out of this. Simply go to animation and then go to the playback. Here we have velocity animation, we have temperature animation. So although this is our steady state simulation here and there is no meaning of animation, but I just, for let's say if you want to run a study transient simulation and if you want to make an animation, how you can do that. So for that I'm showing it over here. Click on velocity animation and then click on play. See, once you do that, okay, so the only 14 frames are there. That is what we may not distinguish between these like video. If you look at closely, there is some sort of disturbance, and then it is flat, right? Similarly, if I click on animation of temperature, see, right? As I said earlier, for steady state solution, this is of no mean, but for transient, you can create animation. Simply click on here, video file, and then write. When you say there are some picture options, like if you want to get some particular image size, or there are video options like you want to get mp4 or mpeg format, or like the scale you want to get 100 or 400, the quality of video best, high, medium, low, right? These are the options available over here. Yeah, so everything is done over here. Now what we will do, we will check the post processing side. So for post processing, we will go to the graphics. Under graphics, we have contours. Already we can see contours over here. See, this is the contour where we are drawing it. We are drawing it at center plane, which is plane 4, right? Now, if you want to see the temperature contour on the wall, that also you can see. This is how the temperature behaves at the wall, right? Similarly, you can see velocity. This is velocity at this thing center plane. What if you want to see velocity at wall? You will see zero, because at wall velocity is zero. So if you want to see the velocity at somewhere away from the wall, because definitely we know there is at wall there is a no slip boundary condition, so definitely we will get zero velocity. But away from the wall there will be some velocity. So for that you need to create a surface where you can draw this thing velocity, right? So right now this it is not here, but we can draw this thing pressure. So for example, pressure, I'll select auto range. This is how the pressure wave, right? So pressure goes from minus to positive. So minus 6, this blue value here, if it means here there is a some sort of recirculation is happening, or maybe more clearly we can see it over here. See, this region is your circulation region. That is what we are getting negative pressure, and here it is higher pressure. Okay, this is higher pressure side. I'll show you velocity vector as well. Velocity vector at plane 4 and auto range. Okay, uh, let's select arrow and oh, they are quite big. Make them down. See, so this is how the velocity vector behaves. So as I said earlier, here there is a circulation, and because of that circulation, there is a negative pressure region, right? So this is how now for a CFD engineer, if he or she wants to rectify this problem, then what we can do, we can make some sort of curvature over here, so that the smooth airflow will be there, right? And because of that smooth airflow, there won't be any recirculation region over here. So ultimately, if you see, although the pipe diameter is 3 inch, but the effective pipe diameter is only 2 inch, or nearby 2 inch, the red region basically. Right? So and then last but not the least is your path line. So here we will select path line as, let's say, temperature, and the path line starts from cold as well as hot inlet. And okay, let's see what it shows us. We will skip few. So this is your path line.
Okay.
More or less, I'll show one more option. Okay, so I have made the wall as transparent, and now check how the path line waves. Let's make it 10. See, so this is how the path line waves, and as you know, this region is of negative negative pressure region. That is what there are some sort of vertices formation, and we can animate this as well. So click on pulse. So this is how the animation will look like. So this is pulse animation. You can make it as a continuous animation as well. I'll show you just one second. Click on continuous and then click on. So now this is your continuous streamline animation. Now, okay, let's stop it over here. Yeah, so that's it. This is all about hands-on CFD. It was a simple problem. I think you can also try the same. Uh, uh, Actually, I wanted to show you one more hands-on, but already it's 5:15 approx. That was regarding the frame motion and mesh motion. Let's say there is a in a room there is a fan, and what happens at the corner of the room when fan is rotating at certain RPM. So that kind of thing I wanted to show you, but anyway, the time is already 5:15. Yeah.
Sir,
So
sir,
yeah,
in
please tell me.
sir, in boundary layer, how do we? You have taken 5 layers, no, sir?
Yes,
Here.
yes.
So how do I capture those informations only in that layer?
Yeah, so that actually you can calculate with the help of y plus value. So generally, what happens? It actually depends. Like if you are taking k omega model, then your y plus value should be less. There are some criteria, like the y plus value should be between uh, 1 to 5 if you want to capture. Uh, in boundary layer there are further three reason. One is sub laminar sublayer. Then there is one more reason. I forgot the name. I think it's a uh, overlap reason, something like that. So anyway, there are three reason in boundary layer further. So if you want to uh, capture the boundary layer more precisely, then better you keep your mesh thickness with y plus within 5. uh, I think I have made you confused, right?
No, sir. Sir, I want to know. That is okay, sir.
uh,
But how do I capture in this software that physics of that? How do I capture that? That is okay, sir. That
uh,
how
uh,
do I
y-
capture here in the model, sir? That is
okay,
what I.
you wanted to see how can we plot y plus and all, something like that.
Sir, in the boundary layer region, sir. Only in
Okay,
the boundary layer region. Sir.
just 1 second.
Yes, sir. Thank you, sir.
Okay. Under turbulence, I think it should be over y plus.
Mm. Hello, am I audible?
Yes, yes, Vijay, please tell me.
Uh, Jagdish,
Yeah,
am I audible? Hello.
Yes, the
Yes,
wish
yes,
you are audible.
please.
Divesh.
Actually, this is laminar case, I think. So a Y plus means
No, no, it's a turbulence case only. That is what we are getting
it is that
air
is what
receivers.
it's a laminar or turbulent.
No,
Turbulent, turbulent.
turbulence will be there inside also, na.
Uh,
So near to the wall, no, he is representing everything.
So Dvesh, what I have done is we can capture the contour of Y plus on the wall. So if you see here, uh,
hmm,
uh, the red region is having is maximum Y plus is 125, right? And the blue region is having minimum Y plus, which is 12. So that means when you are making a boundary layer or the inflation layer basically, your Y plus value should capture these range actually,
hmm,
so that the flow physics will be well captured well. And definitely see what is happening after mixing over here. See the cold fluid is entering from the bottom, and the hot fluid is entering from the top, and ultimately they are mixing over here. So that is what here we need high Y plus.
Mm.
I think no, Y plus should be less. No,
Y plus
Y
should
plus
be
should be less.
less, na.
That is why Y plus should be less here. Yeah, correct. Y plus should be less. That is what here we are getting this blue sign, no? Hello?
Yeah, you may please continue.
Yeah, so again, if okay, anyway, what we'll do, we will uh, how to tell you. See, earlier, if you remember, like just 1 second. Who has such a good laugh? Yeah, so here if you see this particular region, here we have more circulation. And I think this can be well captured if you keep Y plus minimum. That is what if you see contour, another contour, where it is contour one, yeah, this one. That is what we are seeing here, this blue color, which basically belongs to minimum Y plus. So, sir, am I able to tell you your query?
Mr.
Hello.
Jagdish.
Yes, sir. Yes, sir. Thank you, sir. Thank you. Thank you, sir.
Yeah,
Maybe if still there is something, maybe you can write to me. I will check.
Yeah. Yes, sir. Yes, sir. Sure, sir. Thanks,
Okay.
sir.
Thank you.
Thank you very much, sir.
Thank you.
yeah. Even on plot also, these Y plus values can be retrieved. If somebody will be interested to know.
Yeah. Sorry.
I'm just adding with the solution you are providing. I'm
Uh-huh.
saying if somebody will be interested to get the Y plus value, yes, he can also get it from the plot.
Yeah. That also we can do. Yes, we can do. So for plot, there are options. So you can see
Yes,
under
yes,
plot,
yes,
you
yes.
can.
So any other question, participants?
any other question? Hello, participant. ये कोई बदमाशी कर रहा है
करता हूँ उसको.
रिमूव करो
Okay, okay. Sorry for the since Mr. Vinay, I think there's no more question.
Mhm.
You have explained very well, and I think it will be great learning to everyone, and it can be the best hand-on training session on ANSYS. So, would like to thank you, a lot thanks to you. You have spent lots of time, and I think it's very exhaustive to you as well. And with the great energy you presented everything. So even for us, it was a great lecture to attend, on ANSYS. It will even clear my doubts as well.
Yeah.
So it will be highly helpful to all the audience, and participants in this video will be available. This lecture is available as a video on YouTube, where we are streaming. So thank you very much, Vinay, and
Yeah.
Dr. Ramesh, also to request you to present, lab session on our HTC in second day.
Mhm. Yeah, and I also would like to thank you for giving me for giving me an opportunity to meet you all. And I'm really very sorry. In between, there was some sort of some delay because of license issue and some. I'm really very sorry for that. And again, thank you for listening me patiently for 2 hours. That is bigger challenge for you. Anyway, thank you so much.
Thank you, sir.
Thank you, sir.
Yeah, thank you.
Thank you. Thank you all.
Thank you.
Okay, so we will resume tomorrow again from 10 a.m. For the lecture session.
Yes.
Thank you, sir.
Dr. Devesh, tomorrow's session is by Engineer Sunil Kumar. He will be taking which problem?
And that is workshop sessions.
Workshop
from 10
session on structure related problem, you said?
Yeah, sir. It's a
Yeah.
structure.
So he will be basically taking care of structure. Then he will touch upon vibration of the structure as well as some sort of some noise problem also he will take care. Right.
Okay.
Means in the thermal systems, right?
Yeah. Thermal system in the sense like let's say we generally deal with air conditioner, refrigerator, chest freezer
Okay,
and
okay.
all.
That's
So yeah.
okay.
Okay.
Thank
Okay
you,
then.
thank
Thank
you,
you
Mr.
then.
Vinay. It was really very nice, hands-on training.
Yeah.
Started from very basic, and you covered almost everything, which is required.
Yeah. Thank you, sir. Your words means a lot to me. Thank you so much.
Thank you, sir.
Okay. I then. Okay, then we shall
And
leave now.
Okay. Okay.
Vinay, am audible?
Yeah,
It
audible,
will be
please.
audible, please.
Dr. Rajiv Kukreja, sir, is actually specialized in the refrigeration and air conditioning. He
Okay,
is
okay.
teaching that subjects, in the NIT Jalandhar from the many
So,
years.
if tomorrow's session could be dedicated for some RAC application, then it will be nice. But it depends upon the expertise of the speaker.
Experts in
Yeah,
Yeah.
developing it.
What I'll do, I'll ask Mr. Sunil to touch upon the
yeah, if,
areas which are more related to with the RAC.
yeah. If it is possible, I mean,
Yeah, sure.
Not like
it is the expert who has to decide actually.
Yeah. Fine, fine.
Okay, thank you.
Okay.
Okay. Thank you,
Okay. Thank you,
Vinay, once
everyone.
again. Thank you so much.
Yeah. Thank you.
सतेंद्र,
जी सर.
आपके पास वो सुबह वाला जो लेक्चर था डिजिटल ट्विंस वाला, उसकी एक्चुअली मैं देख रहा था यूट्यूब स्ट्रीमिंग है पूरे सेशन की?